Have these guys got an assignment or anything like that?
They do have, yeah.
Oh, excellent. Okay. Well, hopefully, right, I might actually sort of cover some of the... all the notepads get out now, look. Oh, it's starting to get interesting. Oh, marks mean points mean prizes. Excellent, okay. So, I'll try and actually sort of cover, okay, most of it. It's sort of attentive. As long as you're attentive, you'll pick up the messages. Okay. I'll split you into two groups when we go down there. My presentation lasts about normally about 50 minutes, an hour, and then we'll go on the plant, and I'll introduce you to my environmental technician, and she's done this presentation before, and so she'll be able to help you with any other assignment questions. All right? Right, let's just kick off with an introduction to, if I can work the technology, Veolia. Excuse me.
And environmental issues of demographic growth, increasingly scarce resources, and global warming. How do we respond to the needs of industrial production? Recycling and recovery are part of the solution. That is the business of Veolia Environmental Services, a global reference and the only operator active across the waste sector. Each year, the world produces 4 billion tons of waste, only a fourth of which is recycled or recovered. That provides some sense of the industrial challenge Veolia Environmental Services tackled early on, pioneering technological innovations that transformed the waste business and responded to the objectives of improving public health and protecting the environment. Turning waste into a resource means processing information, assessing potential outlets for the resources produced, and installing the industrial equipment required. Introducing innovations into traditional sorting processes. Handling end-of-life equipment of all kinds. Land remediation. Managing industrial services. Maintaining production facilities. Extracting the critical materials that are the lifeblood of high-tech sectors. And regenerating hazardous industrial effluents. And always treating everything, tracing everything, and removing any pollutants before recycling. In its energy recovery facilities, Veolia Environmental Services converts waste into energy and supplies heating and electricity networks. Provides industry with refuse-derived fuels. Manages the breakdown of organic waste or compost. Produces biogas that supplies cities with household gas and vehicles with biofuels. And innovates by producing biodiesel from the transformation of waste cooking oil. Veolia Environmental Services employees do all these things across the world, strengthening partnerships with municipalities and industry. They help create a circular economy. Raw materials, alternative energies, and renewable fuels. By combining all types of recycling and recovery, Veolia Environmental Services turns waste into a resource.
Okay, so one of the phrases that got mentioned there, which I think that you will actually in your lifetime hear more about, is the circular economy. Oops. Any ideas what we actually mean by this? Who's actually heard of that expression? Okay. Where do you live? I'll turn that buzz off. I'll give you time to digest that. It's a really challenging question. Where do you live? Sorry? Solihull. Excellent. Okay. Bigger. Where else do you live? Earth. Excellent. And how big, according to Mr. Hawkins, okay, that wonderful gentleman, is the Earth in compared to the solar system? Wow! Challenging questions first thing in the morning. Maybe I'll ask it just after 10 o'clock. I'll give you a clue. It's like very small. But we all live on it. Okay? All of us. Alright? Anybody seen the film? It's a really easy question, this one is. It's a yes or no. Anybody seen the film Wall-E? That's the Earth. That's the Earth, okay, as predicted, okay, for the future. So all of your children's children will take off, because guess what? This little planet, Earth, okay, that we've lived on for a long period of time, we've messed up. And we've used all the resources, because guess what? That's the kind of society that we've lived in. Okay? And I'm an old fart, as you can see, with my grey hair, probably to a certain extent, I've actually sort of messed it up a little bit more than, hopefully, you guys will do. Because you guys will take care of that little planet, because that's all you've got. Okay? And you don't want to end up with a planet looking like Wall-E. So that's why, hopefully, right, we're starting to introduce this concept of, not the throwaway society, but a circular economy. Right? That's where you guys come in. Okay? Because you wonderful students are the answer to it all. Because you've chosen a profession that I believe, right, will actually find solutions we don't yet have to deal with all of that waste and turning it into a circular economy. I can't sit down from my soapbox, right? But I think, right, just to put things in perspective, right, an area of business that never really gets considered, I think, for some of you, if you really get into it, okay, there is a whole world out there for you to actually come up with innovative solutions to deal with the issues that we're actually now facing. Right? It may not be in this country, it might be global, but you've got to think global nowadays. Okay? So I can see a mixture of students. Do we have a mixture of students in Birmingham? Yeah? From all around the planet. Right? This little tiny speck in the universe. So, where do I, that's hopefully if I can work the technology, why can't I work the technology? Why isn't that working? Work the technology. Okay, so you've come to a facility, right, that sort of sits here. This is a directive that's actually sort of come out of, where do you think our country is now controlled from? God, I'm back on my soapbox again. Okay, where do you think that's come from? EU. Well done. Strasbourg have said, this is the waste hierarchy that all EU countries, because we want to take care of this little planet that we look after, okay? And they've actually pushed this out, all right? And so everybody in the EU is trying, okay, to follow this hierarchy, okay? And what they've come up with, let's not, okay, build waste into the stream in the first place. Right, one example of avoidance, and there's big, huge organisations trying to help, okay, trying to avoid put waste into the stream in the first place. Who eats? I exist, therefore I eat. Okay, keep your hands down. Alright? Who eats microwave meals? Yeah. Okay. Who knows how to work a microwave? Okay. Ding. So why, okay, and initially when we didn't know how to work microwaves, you had huge amounts of packaging on the outside of these little plastic boxes telling you, ding, 30 seconds will do the rice, ding, 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 does your chicken jalfrezi, okay? So why do you need all the packaging on the outside, all right, to tell you how to actually go like that with your finger? So I'll make it very simplistic here because it's first thing in the morning and I know what you're doing. Okay, so what you've actually got is huge organisations like that saying, look Mr Tesco's, look Mr Sainsbury's, stop putting this packaging in the whole process, and that's just one example. So avoidance. So if we've got it in the system in the first place, let's not try and actually reuse it. Okay, that's where this circular economy is starting to cut in. All right, let's reuse it. One examples of that are that your predecessors, right, all invented a wonderful thing called plastic. Okay, it's down to you guys. Well done, ticking box. But it lasts a long time. Okay, but it slightly deteriorates, or we want to get rid of it. What are you going to do with plastic? Let it in the ground, or do something with it? And you know better than I do that if we actually reconstitute that plastic, if we collect it and reconstitute it, we can make that into another product. So there are whole firms now coming up with plastic bollards, plastic vents, seating, planks, okay, to actually try and reuse some of that wood, some of that sort of plastic that's gone into the system already. Reuse. Okay, next, recycling. First stage recycling. Where does that take place? Some challenging questions here. First stage recycling, where does it take place?
At home.
Home, yeah. So we're all doing our bit to recycle, okay? Second stage is that around the city centre, and I'm assuming you all live in the city, because you go to the uni, whether you come from anywhere, okay, you can actually utilise some of the CA sites, civic amenity sites, and recycle. So if we recycle and actually set it up, okay, members of the public can actually recycle. Areas of recycling that's really taken off, okay, because we've introduced more legislation, is electrical goods. Who's had a cathode ray tube television in their life? Who's got an LED television? Okay, so what have you done with your cathode ray tube television?
It's still there.
So still going, it's still going, okay, good, yeah, it's reliable. But that was invented some, what are we now, 30, 40 years ago, okay? But we've all moved in that lifetime, because most of us have probably seen an LED flat screen telly now, because that's the norm, okay, on a wall somewhere. So what do you do with all of the products that we put in here, okay? So, silver, arsenic, all of the stuff that actually went, mercury, all went into those televisions back then, in the 1950s, 60s, right, we don't use now. But it's sitting there as a product. In some cases, there's gold, you know, copper price, whoa, has that taken off recently? So rather than chuck it in a site somewhere, let's reutilise it. So there's a huge emphasis on recycling of those products because there's a real good value in those products, yeah? So if you can't do any of that with it, right, let's recover the energy. So I can take all of your black sacks, all right, and through the process that I'll talk about in a minute, recover energy to provide, so you can see, because it's dark outside, so you can feel a bit warm, okay? So all the heat and lighting, okay, comes from that plant here, now in this room. And I think this is where you guys will actually sort of come into it. So if you can't do any of that with it, let's get products, okay, and treat them. So one example that's actually sort of coming out, so paint for instance, paint, oil-based, synthetic paint, okay. If you can't utilise all of that, this ends up with waste. So chemical engineers, right, have designed a methodology to take all that out, clean it all up, and give that oil to somebody else who could actually use it, okay. So that's a form of treatment, all right. The last but one is containment. So you've got this waste, hazardous material, let's contain it so it doesn't destroy the planet any more than it can do. Let's contain it. And I've got some product down there that I'll talk about that we contain, right? Because at the moment we haven't found a solution. Well, I'm looking to you guys, okay? Because when you pass out, you'll find a solution for it, all right? Last of all, which is where, you know, we've put stuff in the past, disposal. Where would you think we'd put it now? Ah, here it is.
Some of the bags are
No, we're on here for an hour.
Are we?
Yeah.
Grab a seat.
One of my new engineers, he's come to listen. Because he's interested. Yeah, there's somebody in there, mate.
Yeah.
Have to go into case. Disposal. Where do we put waste that we can't do anything with? Where do you think we put it now? Landfill. Describe to me a landfill site then. Excellent. Hey, we work together well. Okay. Briefed him well. A hole in the ground. Okay. But if I say to you, anybody been around Birmingham Airport, M42 area? Okay. There's a landfill disposal site over there that isn't a hole in the ground. Okay. That hole in the ground 15 years ago, you're right, 15 years ago, but all the rubbish that we've now collected, okay, is now up there, like that. Okay. Sufficiently high enough to actually cause a big, big problem for any of you who actually use Birmingham Airport. Because it's now an air traffic problem, that landfill site. So they've requested Birmingham City Council to put traffic warning notices on the top there, flashing beacons, right? So that is the landfill. It's coming back to what I've said to you, right? We're a tiny planet. We're running out holes in the ground. So we, and I'm using the collective we, because you guys will find a solution, right, for that waste. Okay? Some way or shape or form, you will find a solution not to bury stuff in the ground. Alright? Yes. You need to sit. Sorry about this, guys. Well, my lecture's gone sort of. I'm global. So, yeah, landfill is a thing of the past, and we're running out of spaces, alright, to put the waste that you and I produce on a regular, daily basis, alright? So, we've got to find solutions to it. So, disposals are the last one, alright? And this is what we're actually sort of having to deal with, right? So you and I collectively push out somewhere in the region of about 24 million tonnes of rubbish each year. Okay? And so around about 50% of that, 50% of that actually goes to landfill. So we need to find a solution, alright? Because we're just running out of spaces. You know, in America they ship it out of New York on barges. Alright? So what we've come up with is we can actually sort of take all those black sacks that you actually sort of push out in your efforts to recycle, alright? And I can actually convert it because it's got around 9,000 kilojoules per kilogram calorific value in those black sacks. So I can burn it in specially designed power stations, right, in here, alright, without the use of any kind of fuel, which is, to actually sort of kick it off, it's usually gas oil. We use gas oil to actually kick it off the process. Okay, so some of the benefits of having one of these plants on your doorstep. First off, we're getting a lot of waste from Birmingham. I'll come on to talk about that in a minute. But it reduces, the process reduces that huge volume of waste by 90%. So I end up with a 10% product at the bottom that I have to deal something with, alright? So it minimises landfill, which is the subject we've been talking about. Okay, the biggest one here, okay, that I talk about is conserves fossil fuels. Okay. So we all live in Britain. So this plant isn't here. So where do you get your electric from there? So you go home of a night time and you switch your lights on, put your electric shower heater on, oh nice and toasty, oh put the telly on, where do you get your electric from there?
Coal power stations.
Coal power stations, yep, well done, about 30%. But what's interesting about coal in the UK, where do we, in Britain, get our coal from? Where do we get the coal from? Have we got loads of mines? No. Okay. Because we shut them all. Where the movie Billy Elliot came from, isn't it? Because we shut all the mines down. Right. We shut the mines down, so where does the coal come from there? These power stations are working. What are they doing? Burning fresh air.
My guess would be the EU.
Not as much from the EU, no. US? Not the US, no.
China.
A little bit coming out of China, not much. Indonesia, Australia, okay. Bit coming out of South America. All comes across to Rotterdam and then shipped across to Harwich and then distributed around. What was the actual use? I thought we were actually sort of trying to save the planet from CO2, transport costs of actually, you know, to get that here of damaging the environment as we were actually sort of doing it. So that's just coal, okay? Coal 30%. Where else? So some of you, if you don't know this, you're going to be short of electric this winter. Because it's not going to be there, so 30% of you are in the dinghy because they're, you know, producing by coal. Okay, I'll give you that. Where else? Gas. Okay, well done. What happened to our North Sea gas? It ran out. So yeah, so where do we get our gas from there?
Overseas.
Which overseas country?
America?
No, too far. Where's the network? Go and have a look at gas networks in the North Sea because we laid some really good pipes there. Russia. Okay. So we're dead friendly with Mr. Putin, aren't we? I don't think so. I think he's actually sort of taken a stance with the Ukraine. You don't pay up, I'm going to shut this big valve coming out of the Russian oil first. Okay, and the gas first. So yeah, so gas. Gas, I think it's around sort of 15%, something like that. Okay, what else?
Small amount from nuclear.
Nuclear, excellent. Nuclear, well done. How old are our nuclear power stations?
Still pretty young.
They're pretty old. Okay. What have we just done? Okay, with that wonderful country called China.
Oh.
They're going to build us 2 new nuclear power stations. Okay, but guess what? What are you good at? Are you from China?
No, sorry.
Okay. Where are you from?
Malaysia.
Malaysia. Okay. I love Kuala Lumpur. Okay. Love it to bits. China has actually just done what China does best, and that is they strike good commercial deals over a long period of time. So the price of electric at the moment, if you look on the stock market, is around about £50 a megawatt hour. Okay, they've struck it for £100 a megawatt hour for those 2 power stations. So you guys, and me, will be paying for that for the next 35 years. Okay, that's why they did the deal. They love it. Okay. The other one that you haven't mentioned, spinny things in the North Sea and onshore, renewable wind. Okay, and wind. Interesting enough, when those high winds were about the other week, they were actually supplying more power than the nuclear power station. So wind has taken over from nuclear. But it's intermittent. That's the problem with wind. So we're sitting here, okay, and sort of UK wide with 240 odd megawatts, but we are doing our bit because we're burning all the refuse, right? And so we're trying to actually sort of conserve all the fossil fuels that we talked about. So having one of these on your doorstep isn't too bad an idea, right? Recovery rate not brilliant, around about 20%, but we're burning waste, and that's our main focus. Gas-fired power stations upwards circa about 50%. It reduces greenhouse gas emissions because we've got better back abatement systems than a coal-fired power station, and it minimises the haulage of waste around the city centre. And that's what all of these big plants are trying to do, stop that haulage of waste around the site. We recover all the ferrous metal, all right, and we actually use that 10% that I talked about in construction. So the biggest things, okay, that are a worry to having one of these on people's doorsteps are, and we've tried to actually bring it down to these 3. So the major source of pollution, we don't need them because everybody's going to recycle, and we've got this toxic ash. Right, so the biggest thing, okay, why is everybody worried about that? Why is everybody worried about that? They should get this, chemical students, they should get this straight away. Let's just call that off. Dioxins, what do they do? Why is everybody interested in dioxins? In particular, we see the 20s and 10s, small little atoms that do what? So, what? Sorry?
The ionize cells? Are they carcinogenic?
Excellent. Yeah. Well done. Top marks. Give that man a chocolate. Yes, they are carcinogenic. All right. However, okay, every combustion process, produces dioxins, and it's the level that we're trying to control. If you can control the level, right, we're in a good position. So, but we've passed a whole series of laws, all right, that actually makes you guys look very healthy, you know, because the air that you breathe, that 21%, okay, has been cleaned up because we've passed the Clean Air Act in this country. So all that air, so we don't only get that London foggy town smog, all right, that is choking everybody, okay. Was it Singapore that got choked?
Yeah, it was
Yeah,
Singapore.
okay. So they haven't got these laws in the forest, but you can see the effect of it, and it's really quite stinging. So let's have a look at the biggest contributors. What are the biggest contributors? Combustion process. Okay. You mentioned it.
Cool.
Coal. Okay. So we've still got all these power stations, and it's actually sort of producing all these dioxins as we burn coal. Okay. How have you got here today? Good to see. On a big bus. Right. So traffic. That's a big push to try and actually sort of get those emissions down from cars. That's why there's a big push to actually drive those emissions down, because as well as the CO, right, they're also producing dioxins. That's why there's this big push, okay, to get those emissions coming out of cars down as low as we can. All right, what is this area famous for? Sorry? Curry! Excellent. Well done. Yeah. And how do you get curry onto an island?
You ship it over by.
Yeah, if the island is close to a mainland. Fly, okay, yeah. I just sort of walk over a bridge myself.
Oh yeah.
Okay. So we had the first iron bridge, all right, in this area. It's called Iron Bridge, all right, because we had lots of foundries, smelting works, and the like, polluting the atmosphere. Who's seen Pinky Blinders? Pinky Blinders? Yeah. Okay. That's just literally down the road. Try and just do one episode if your stomach can take it. All right. Just do one episode. Smog, smelting. We're known as the sort of black country, right? So metal processing produced huge volumes of actually sort of dust and dioxins in the atmosphere. One that you won't even be thinking about because you're so young. Aren't they so young? Okay. But what else could it be? What's the opposite of young? Okay, and where'd you go? Okay. So you die. Okay. So you die, and you know it's a combustion process, producing dioxin. So at the end of your life, you're going to cause a problem for your brethren coming forward. But what's the biggest contributor? All the ERS put together, what's the biggest contributor of dioxins? Think of a combustion process, and a big one.
Forest clearing.
Sorry?
Forest clearing.
Forest cleaning, yes, like that one. Yeah. In the UK, we haven't that many forests. Just in the UK, what's the biggest one in the UK? Yeah.
Waste incineration.
No. Not waste incineration. I'll come on to talk about that one. But waste incineration, right, is small in comparison to this one. I'll give you a clue. What's the date today? What was the date on, where are we? Wednesday.
Bonfire night.
Bonfire night. Well done. Okay. Biggest contributor, okay, by a country mile, because it is an uncontrolled combustion event, because everybody decides to put their rubbish onto a main street area. Oh, let's put a railway sleeper on there. We painted in creosote. Let's just throw everything on there. Okay? And guess what? Okay? You end up getting, right, a combustion event that produces more dioxins. In fact, so much so that Birmingham, when they used to have a bonfire, and I think they cancelled the one in Pye Bays Park for whatever reason, they say it's health and safety, because they used to have to suspend the Clean Air Act in Birmingham, right? And I don't think they've had a bonfire this year in Pye Bays Park, because after the event, you go out and you can smell that sort of sulphury type, different pungent smell. I haven't smelt it this year, but you know, you get that sort of effect. But if you burn products in an incinerator, as long as it's a modern one, there are no dioxin levels detectable going out there that's going to cause any harm, right? And these are some of the run-throughs that they've done, you know, around the surrounding areas to actually demonstrate that if you run a modern incinerator, and I'll come on to talk about how a modern incinerator works, that there are no really major health effects, all right? And they're actually rerunning this one. They're rerunning this particular test. So they have all of my figures. All of my figures for the emissions go onto my website. So if you want to go on the website, look at Veolia, ties the energy recovery facility, and you can see all of my emissions. Okay, so that's dioxins. So, yes, there is an argument about don't have waste. Don't have waste incinerators. Because guess what? You, and you, and you, okay, are going to do what? You've got all this waste, what are you going to do? What are you going to do with the waste? I'm not going to put it in landfill, so what are you going to do with that waste? A big fine, okay? What are you going to do with it? Hopefully, right, you're going to tell me that you're going to recycle everything because you're fired up and you're going to recycle every bit of waste that comes into your household. Okay? Well done. Well done. Thank you. Well done. Well done. Okay? Well done. They followed a family, right? I think it was like the equivalent of the one shows nationwide. They followed a family for a year. And yes, they did exactly what you three guys are going to do. Recycled everything except for a black sack. The one black sack. So I'm not here. Okay, no incinerators. No. No landfill. So what are you going to do with that black sack? Hopefully you guys are going to tell me that there's a chemical solution to it. Okay? That will happen in the future. But at the moment, right, for that black sack, they tried ever so hard and they ended up giving it to an incinerator and burning it. Right? There's 60 million of us living in this country. That's just one family producing one black sack. Okay? So we have a problem. We have a problem. So you need, right, one of these. And Europe actually recognises that. Right? Because look at the stats you've actually got here. These guys are way out in front, Austria and Germany. Their recycling levels 70% and 65%. Right? But they still have energy recovery facilities to deal with that one black sack. Because they're not putting hardly anything in landfill sites. In fact, Switzerland, bless them, in their chocolate, mountains, well-grown straight mountains, haven't put anything in the ground, right, for years and years and years. They're thinking. In Germany, anybody lived in Germany? Okay. In Germany, you have to recycle. You have to recycle. Because you will recycle. If you don't recycle, you get fined. God, it's a double act here. I'm glad you came, Jeff. Right. You get fined. Don't ask me anything now. Okay? Because you get fined. Anybody been through a German airport? Yeah? In that German airport, there are always tri-bins. Plastic, paper, rubbish. Plastic, paper, rubbish. Okay? You're looking at how many, right, those tri-bins are in the UK airports. Okay, we're not geared up. These guys are way out in front because of their mental attitude that they do when they get found out. And they would do it because they're morally really geared up to the environment. Hats off to the Germans and the Austrians because they're way out in front. Okay, UK. So we're recycling, and some councils are recycling around about 40%, but we haven't got sufficient ERS at the moment, energy recovery facilities. So we're still sticking this huge volume into landfill. All right? So we need to find a solution. And this is where we are. Okay, I know I've been hard on you because I'm a little bit on my soapbox about this. Right, but we are running about 10. Look at our new European partners, Romania and Bulgaria. Anybody been out to Romania? Put it on your wish list to go. It's a really fascinating place, right? Go to Dracula's castle, right, and get yourself really scared. Talk about our Halloween, you want to see what they do over there. But when you drive over the wonderful sort of mountains and you drop off for a picnic, you're doing this. Because you're trying to avoid all the previous people's picnics rubbish and not got it thinking. So we are up there. We are up there. But I think we need to actually find a solution, right, to some of the rubbish that we've actually got. And these are some of the targets that the government has actually set. And they've also, and the reason that everybody's interested in trying to actually build these plants is that there is a big tax on people putting stuff into landfill. Because a wonderful politician called 2 James Prescott said, you can't have free access to that ground. So what I'm going to do is tax it. So I'm getting 1,000 tonnes of rubbish, 1,000 tonnes of rubbish per day. Alright? 350,000 tonnes of rubbish per year. Think of the financial impact, okay? And it will eventually go up to 100, 200 pounds a tonne on the residents of Birmingham if that were to actually all go to landfill and I wasn't here. Alright? And the other area that is really interesting, which I think you guys could actually help, is in biodegradable waste. Anybody been to Brindley Place? Wonderful place. That's where you get your curry from. Okay. You want to see what comes out on a Monday. 2 days worth of supply of biodegradable waste. It's not a pretty sight. But that's why there's this big spring up of anaerobic digestion plants. You've heard about those? Yeah. And those are the ways forward at the moment, but we don't think, right, it's the final solution. Because I think the final solution probably sits within this room. You can find a methodology, right, to dispose of food waste in the home. Boy, your fortunes are made. They are the tip for today. And that's what they're trying to target, okay, trying to reduce the amount of biodegradable waste going into landfill. So the city itself, we're all part of, 1 million plus inhabitants, around about 500,000 homes, and this is what I'm having to deal with here, around about 500,000 tonnes of waste. And that's the sort of recycling that we've actually got taking place across the facilities that we actually provide. And this is Birmingham's recycling target as, or sort of achievement so far, and it's sort of plateaued out at about 30%, 32%. So that's what we're introducing wheelie bins. Anybody introduced to wheelie bins? Anybody in digs with wheelie bins at the moment? Any words? No, okay. So we're trying to get that up to 40%, because if we don't meet those 40-45% recycling target, the government will fine local government. And so that's why there's a big push on that area. So all of that product, which gets collected out of those bins, goes up to a MRF, a materials recovery facility. Okay, so that's recycling. The other myth is that we get large toxic ash coming out the back. We don't. It's not toxic, it's inert. But what we do with it, we actually supply it to an aggregate firm, and they actually sort of screen it and make it into a product that's useful for putting into concrete. So some of our IBA, we call it, incinerator bottom ash, has actually ended up as Marley blocks around the Olympic Park. Okay? And so items like that, it's also gone into the base of the M6 toll road. So, the project itself, it's coming up to the end, about another sort of 4 or 5 years. It's a joint venture between Veolia and Birmingham City Council. They hold the lion's share, so we're the O&M. Okay? And we're still the biggest operator so far in the UK of energy recovery facilities. So the way this contract works, all sort of we're in Untitled, so I get all the central wards. This is all the sort of southern wards going to Lifford Lane, all the northern wards going to Petty Bar, and then overnight those two offload that product into Tisley. Castle Bromwich is where we've got a CA site and also the IBA. Up here we've got a reuse centre at Norris Way, and then way over here at Four Ashes we've got the actual MRF to actually take all the recycled residue to actually be processed up there. Okay, the actual project itself cost around about 100 million. We built a new access road on the Cov Road, built this 350 tonne incinerator, separate clinical incinerator, so that actually works differently to the main plant because that actually works at a different temperature, and we've got electricity grid connection, so we're actually servicing around about sort of 40,000 homes from here. We've demolished the old building and put this household recycling centre in. So to mass burn, we call it a mass burn. So basically it's a moving bonfire. All right. 23 tonnes, 23.5 tonnes an hour. It's Steinmuller design. It's a German design. Most of the plants are actually sort of European because they're way ahead. Austrian, French, all right, and German. I'll come on to talk about the boiler in a minute. We've got a single turbine producing around about 30 megawatts. It varies because of the product we're trying to actually sort of burn, and we sort of send in net because we've got a parasitic load of about 3 megawatts, and so we're producing 25 megawatts. We've got an air-cooled condenser, so you don't actually sort of see loads of plume going off. It's a sealed unit, and then we capture the ferrous metal. Right, the techie bit. So, waste comes in, 1,000 tonnes a day from the streets of Birmingham. It drops down into a shed here, into a bunker. This is 15 metres deep, alright? And so we're pulling up the waste on 2 5-tonne grabs, drops down into a feeder chute here. That feeder chute here pushes the waste actually slowly onto an inclined grate about 12 degrees. It goes into a pyrolysis state, a gasification state, and then it is burned off on grate 3. The air for this, being blown up underneath, actually comes from the whole tipping shed. The whole of this is under negative pressure, so it keeps all the smells, and trust me, you'll all be going down like that, okay, when you walk in this area of the facility. All that goes into here. We've actually sort of got, once it's actually alight, okay, we've got gas oil burners here, it stays alight. You keep feeding it, and the reflected heat from here actually just keeps it alight. You just keep feeding it with raw product. The waste then, temperatures in here have been measured by your colleagues up at Sheffield Hallam University. I put a pyrometer in there and actually measured it at 1300 degrees C. It starts to go down grade 4 and 5. What we're trying to do there is cool it down, so it's just ash. Then we're trying to cool it down before it drops into ash quench bath here, okay, before every sort of 15 minutes gets pushed out as a slug onto some sort of conveyors, moving conveyors, underneath the ferrous magnet, drops down here into two pits for ash and one for metal, and then gets lifted off every sort of day after ballast Phoenix. So you've got all this heat here. That heat is actually going to move up through the boiler, down the second pass, up the third pass, and through the fourth pass here, out to the back end of the boiler here. And temperatures there are really around about 230 degrees. So we've absorbed all the heat in 21 miles of tubing, okay? And we've moved water into a saturated steam state, into a superheated state at 40 bars and 400 degrees C. Lot of energy, okay, in that steam. That steam then passes through a turbine, single HP turbine, through a gearbox. That's turbine spinning at 4,400 revs, through a gearbox, rotor turning into a generator, making electric at 50 Hertz. The steam from that actually passes through, up through here, into the air-cooled condensers, saturated steam at about sort of 35 degrees. What we need to do is move it back through its state again, back into a water state at about 23 degrees. So we can feed it back into the boiler. And we do that through a series of car radiators, if you like, with 8 fans underneath, blowing the air through there and out to cool it down into its, move it through its physical state. So that's the water side. Right. What we need to do, because we're burning all that stuff that you're giving me. There's black sacks in here with all sorts in there. Plastics, metals, everything. Gold, silver. What we need to do is abate all of those gases. So we start the back abatement process by spraying it with ammonia in here to get rid of the nitric oxides through selective catalytic reduction. Interesting area for you to have a look at in here, and we've had to position this because temperatures down here are 1300 degrees C, but the main reason, right, that's that high is that we have to maintain 850 degrees C for a 2-second resonance time to ensure that we get rid of all those dioxins, and that's what modern incinerators have to do. And there is a waste incinerated directive that tells us how to actually construct and maintain these. And if we can't maintain 850 degrees C, we have to shut down, because we know we haven't actually met the temperature conditions to get rid of all those dioxins. So then, the next part of the back abatement process here, we actually spray it with activated carbon. Anybody look to the molecular structure of activated carbon? Another one for you to look at. Yeah, I like this. If you look at it, it's very, very porous. It's very good at attracting all heavy metals, right? So the heavy metals that are actually burnt off at 1300 degrees C, so people's gold rings, silver rings, people's jewellery, all go into a gaseous state. Silver, mercury, cadmium, all go into a gaseous state. And what we're trying to do is capture it by activated carbon. So we spray it here with activated carbon. We then, the gases then come into this reactor tower, it slows down, and we actually spray it with lime to get rid of all the acidity in the gas. We get lime from Buxton, it comes here, it gets slaked into a paste, and actually gets sped into an atomizer here, so that it actually literally passes through a mist. All right? What we're looking at is before HCl levels at about 900 milligrams per cubic metre. Back end here, up the stack, around about 4 or 5. That's how effective this process is here. We then pass all those particles through what we call a fabric filter. We call it a bag house, okay? Because it's made up of 8 modules, 310 bags in each module, These bags are 4 metres long, made of Kevlar, okay, so the product actually sticks to the outside, so the gases come out, in, and out again. So it's out, so it's like a giant sock, right? And every so often, we actually blow air through those tubes, right, to actually ripple off all the product on the outside. And we call that air pollution control residue. And that, because it's deemed as hazardous, okay, and that's the only hazardous part of the plant, right, we have to contain that. Because at the moment we haven't found a solution to actually dealing with that hazardous product. That actually gets sealed up, it gets pumped into silos, into wagons, and gets shipped across to a place called Monosis. It's a huge salt mine under the Morecambe Bay, based in Cheshire, goes right underneath Morecambe Bay. Sunday Times did a 3D article on it about 2 years ago. Type that in Google, it's a massive underground mine, basically, salt mine. And so government use it to stick files down there, and we use it to actually sort of get rid of all this product. So we've got this clean gas, okay, going up the stack, 83 metres high, and what we do here, we actually measure it with what we call continuous emission monitoring scheme. So it's analysing the data that's actually going up there, and it's collecting data, right, every 5 seconds. Every 5 seconds, so we can actually predict a minute average, a 30-minute average, and a daily average. So if there's anything going wrong with any part of this plant here, and we're out of emission limits on HCl, SO2, VOCs, dust, we can actually shut the plant down. All right? Questions? Got it? Basically, it's a chemical dream. This plant is a chemical dream. You should be loving this, okay? Because there's lots of reactions taking place here to actually make sure that we've got clean, incandescent gases going up the stack. And that's what modern incinerators, all these modern incinerators that you see springing up all over the place, follow this process exactly. Okay, we're coming back to the circular economy again. It's not new, all right? This is the 1923 plant. And Birmingham then was a big city, okay? And this plant was actually sort of designed by Neville Chamberlain. Any idea what the motto is for Birmingham? God, it's a job. See, it's all sorts of lessons here. Okay. It's what I'm doing now. Forward. Okay, forward is what Birmingham's motto is, and that was the 1923 plant trying to come up with a solution for all of its waste. Alright? Because this also had another feature that we've talked about earlier on today. Right? And that is, it actually had a boiler which raised steam, which turned steam generators to produce DC electric, direct current electric. That direct current electric charged up refuge truck batteries that went out onto the city streets, okay, to collect its refuge. Circular economy in action. Tick. Alright? And one of those is still in Millennium Point now. We have a wet Saturday to go and spend some time. Recommend Millennium Point. So that's where the old plant was. This is the 70s plant. Coventry Road up there. That one didn't comply with the waste incinerating directive, so we had to shut it down. This is in construction, so 1993. And those are the two plants to actually sort of gather. So air-cooled condensers, so there's the sort of fins, and so there's 8 fans underneath here. There's the reactor tower here. There's the sort of boiler house. This is the crane deck, tipping shed. Here's the clinical plant. We have a clinical plant here to take Birmingham hospital waste, and that actually works at 1100 degrees C, because what they found in labs, if you to get rid of all the pathogens, okay, that you've actually got in products like tablets, you have to burn it at that temperature. So that is basically an upscale crematoria, okay, with 3 rams in it that actually produce heat, passes it through a boiler and into the main plant. So we get low grade heat, about 10 bars low grade heat, which makes that main plant efficient. All the product that comes out of here goes and is actually tapped into just before the reactor, so it's picking up all the back abatement equipment that's actually going on there. Okay, this is my plant at night, courtesy of your electrical department at Birmingham University. They won a prize for it. I've actually enhanced it by actually putting some LEDs on there, because you can get some better colours out of LEDs. It also reduces my CO footprint, which we're all interested in. These are some of the other plants that we've actually got. They're obviously sort of more modern than mine, but they work exactly on the same principle. This is Portsmouth, in amongst all the retail parks. This is Chinham. Now this one's sort of next to a sewerage works, but it's also got a visitor centre running right through the centre, so in glass, so you can actually sort of keep protected. This one here, council made us go through the hoop a little bit to actually put all of what you see out there into a very nice shiny dome. Because just here is Southampton Water, where all the liners come on. So Hampshire Council didn't want people coming up along there going, oh, it's a messy waste incinerator. Okay. So they made everybody put in there. That's my equivalent's office there. So we looked over Southampton Water, very nice office. Selchip, right next to the Millwall ground. Sheffield has got a district heating scheme in, so that actually services Sheffield and Hallam University, the Crucible, heating and cooling, and the council offices. So some of these facilities on the continent are utilising that district heating network, and that's why Switzerland and Austria have actually got lots of these little plants, all burning waste, but then producing a district heating scheme. And that's the way Europe's actually sort of set theirs up. This one here is next to sort of Brighton, Newhaven, and that there was a limit on here, 23 metres, so they shoved everything down in the ground. It's on a floodplain, so it's really quite an interesting, challenging little bit of kit. That one up at Battlefields at Shropshire will be taking sort of 90,000 tonnes of Shropshire's waste and putting it into here. 4 Ashes at Staffs, that's just actually sort of got commissioned and running now. And then this one here on construction schedule, as far as I know, all reclaimed timber. Okay, here those arches are reclaimed timber, and this will have the highest living wall in Europe when it's finished. All, you know, trying to actually sort of work with the local council to actually make them look, you know, a little bit more friendly. If you go on these and look at some of the Japanese ones, they have got some wacky art on them. So right, so questions? Okay. What we'll do, what we'll do, I'll put the safety video on, I'll go and get my gear on, and then we'll have a walk down the bottom there. Let me just put the, you've heard enough from me,